So, hi guys. In today's session, we will be discussing regarding hydrocarbons. Okay. So, in hydrocarbons, we should know the nomenclature and everything of organic compounds. So, I'm sure that everyone knows the organic compound naming. If you don't know, I'll help you out. Once session is over, I'll just help you out with the same. Okay. So, coming to the session today, I want to take the most important thing first. So hydrocarbon, organic chemistry, correct? So almost we all have heard that this is a very difficult subject, the organic chemistry. No, the main thing is chemistry is the land of exceptions. Okay. So suppose if I'm telling you that, okay, this reaction is correct. This is the way this reaction is going on. But very next day or in some other class, I myself will say that this reaction is not correct, but another reaction is correct. You got the point. Hmm? So that's how chemistry, it's a land of exceptions, which means I'll teach you one rule that this is correct. Then next day or the next week, I'll tell you that that rule is wrong. Or there is one more loophole in that rule that I can make it to some other reactions. So that's how the organic chemistry. But again, the exceptions are just minor. We only have around 10 to 12 exceptions, but that's again a huge number. Okay, the number is huge. So I'll discuss the most important thing first. So 5 to 6 minutes I need from your end, or just 10 minutes from I need from all of your end. Okay, so that I can just help you out with the most important thing this chapter has to offer. Then rest of things are very easy. The one thing which I wanted to teach first, I need your 5 to 10 minutes of time. Okay, yeah. So let's discuss about Markov-Nikov rule. Okay, what is it? Markov-Nikov rule. I think you can see one reaction here, right? CH3, CH double bond, CH2. Correct? This is an alkene. This is what? An alkene respectively. Yes, this is alkene. Now, what is HBr? Hydrogen halide. Br, bromine, iodine, chlorine, fluorine, all are halogens. Group 17 is all halogens. Correct? Hydrogen halide. Yes, and here something is written. CH3, CH, Br, CH3. So for you guys, I'll just write it down. What they wanted to write: CH3, CH, CH3, then Br. Here, if I number here 1, 2, 3, if I number here 1, 2, 3, bromine is coming in which place? If I'm numbering from 1, 2, 3, bromine is coming in which place? Second position, right? Correct. So this reaction, I told you that this is an alkene, correct? Propene, I can tell. 3 carbon atoms. An alkene plus hydrogen halide plus HBr. I'll write down here in text. An alkene plus HBr, that is hydrogen halide, is giving me a secondary alkane. Is giving me alkene plus HBr is giving me what? A secondary alkane. Kindly note down this thing is very, very important. And this won't be simplified in the book. That's the reason I am just taking this and giving utmost importance. Give secondary alkane, because if you read a textbook, gone. We won't be able to understand this simple. Okay, alkene plus HBr will give me what? Secondary alkane. Correct? So, this reaction actually produces, in the textbook, there is only secondary alkane. Correct? This reaction only produces, in textbook it is only there, secondary alkane is only there. But actually it will produce secondary alkane plus primary alkane. I'll put one as primary alkane. Secondary I will put as 2, secondary means 2 degree, and primary I'll put as 1 degree. Okay, alkane. So in Markov-Nikov rule, they'll say that the secondary alkane is there, right? Yes, this is major component. This is what? Major component. I'll write down here. Major component. In the sense, around 90 percentage or 85% of the product is which one? Secondary alkane. 85% of the product. This is very important. That's the reason again I'm stressing. 85% is secondary alkane. Okay, I'll go back to the reaction. This is my alkene plus hydrogen halide, HBr. Is giving me secondary. Why secondary? I told you because bromine is coming in secondary carbon atom. That's the reason. Bromine is coming in secondary carbon atom. Okay. This is my Markov-Nikov rule. But in the beginning of the class, I already told you this is about chemistry. Organic chemistry is the land of exceptions. So if I say something now, the next thing what I'm going to say contradicts this thing. In the sense, there is something called anti-Markov-Nikov rule. I'll write down here. Anti-Markov-Nikov rule. In the sense, just now I told you what which is greater. So if my spelling is wrong, just forgive me for that. That's not that's not that important. But what I'm going to say is important. Anti-Markov-Nikov rule is, I just told you. I'll tell you what it is. Then you'll come to know what I'm trying to tell. I'll write down. Same thing, alkene plus HBr. Primary, okay, I'll write secondary alkane. Secondary alkane plus primary. Same thing, same equation I'm giving. But only thing is I'll write down here alkene plus HBr in presence of peroxide. In presence of peroxide. This is the only extra thing I am adding. Same reaction, but only one extra thing is peroxide. So can you tell me which component is more? Secondary alkene or primary alkene? See, secondary alkane is nothing but, I'll write it down here, CH3, CH, CH3Br. Correct? Primary alkane meaning CH3, CH2, CH2Br. This is my primary alkane. 1, 2, 3, the numbering here. Here also numbering 1, 2, 3, numbering here. This is my secondary alkane, the down one is my primary alkane. So just now I told you, alkene plus HBr will give me what? Secondary alkane as the major component. Now I'm going to tell you, same thing, alkene plus HBr will give you what? Alkane, but primary alkane is more. Major component is which one? The primary alkane. This is my major component. So that's the reason, first of all, I told you in this class what I'm going to say. Correct? There can be contradiction in the thing. One second. So just as I told you, I just told first what? Alkene plus HB will give me secondary alkane. Alkene plus HBr will give me alkane. But in the first case, what I told you, secondary alkane will be more. But second case, what I'm telling you, which is more? Primary alkane is my major component because if I add peroxide with this thing. So that is the reason it is called anti-Markov-Nikov rule. Again, for the entrance point of view and for the board exam point of view, this is very, very important. And again, you take this. This is the only thing which is coming from class 11 to class 12 transition. Is this thing clear to everyone? Kindly let me know in the chat. And I'll just show you the same thing. Markov-Nikov rule, alkene plus alkene is giving me secondary carbon atom more. But see here, alkene plus HBr is giving me what? Primary alkane more. That's the reason I told you there will be a lot of contradictions. Is it clear for everyone? If it is not clear, once the class is over, I'll help you out with the same. Okay. It's because it's a land of exception. So I think with this now I can start from the beginning. So there are three things I think you know: alkane, alkene, and alkyne. Correct? So how do you prepare alkane? Preparation of alkane. Hydrogenation process. Hydrogenation in the sense alkene from the petroleum products is passed through what? Hydrogen under high pressure. So this double bond will be broken down into, and what will happen? This double bond breaks up and it will have two. What is one double bond containing? Two electrons, correct? So each hydrogen will get attached to it. CH3 under CH3 hyphen CH. So this is basically my what? Ethane. Alkyne plus hydrogen also will give me my alkane. From alkyl halides. Alkyl halides in the sense, what is alkyl meaning? CH4 is my methane. CH3 is what I'm removing on hydrogen. So that is called my methyl. Alkyl. R stands for alkyl. R stands for alkyl. So chlorine, I will say halogen. Halogen is denoted by X. Halogen is denoted by X. Okay. So reduction. So if I add CH3Cl plus hydrochloric acid, HCl. Correct? Then hydrogen will attach with what? One hydrogen here. I'll get methane, CH4 plus H. Correct? This Cl plus Cl will give me Cl2. Free radical. I think this again you have studied in some basic principles of chemistry. So this is all self-readable things. So it's not that difficult at all. Okay. My point here is alkyl halide. Alkyl means CH3. Correct? Yes, halide. Halogen is Cl on reduction. Which means if I treat it with hydrochloric acid and heat it, then I'll get an alkane. And guys, one very important thing I want to tell you. Our topic is preparation of alkane. Correct? So the end product should be always alkene. Just keep that in mind and then study. Okay, don't just by heart and study. Just keep what is required and then study. Okay. So I hope I'm not going that fast. Again, Wood's reaction. This is very, very important. If you study this thing now, next year, the same thing will come. So Wood's reaction, nothing but what is CH3Br? My alkyl halide on treating with what? Sodium. Correct? Yes, and one more alkyl. BRC is nothing but same thing. Alkyl halide only. Alkyl halide only. 2CH3Br. So if you want to make it simple here, let me just. If it is very difficult, this reactions, nothing. Just put 2CH3Br, not NR, Br, plus 2Na, plus 2Na will give me the following things. 2CH3 we got here, right? Plus 2NaBr. That's all. So it's a very simple thing. Alkyl halide plus sodium. Yes, and here in the presence of a dry ether. Dry ether. ROR. Ether equation ROR. So this is my Woods reaction. So all of these notes I'll share it to you. So properties, colorless, odorless, and one more thing, solubility. Alkanes are generally what? It's not at all soluble in water. But in benzene and all, correct? In benzene and all, it is highly soluble. That is in non-polar solvents. In polar solvents like water, it is insoluble. Only non-polar solvents. And guys, don't take these things very lightly, because for the entrance point of view, whichever we think it is very light, from that only they will ask. So physical and chemical properties are a must in entrance. And again, coming to boiling point. So each and every line is important. This again can come in options in the entrance. Simple questions, but it will twist. They'll twist and they'll ask. That's the thing. So obviously, the questions will be like, which will be having a higher boiling point. Methane, propane, butane, hexane. Methane, propane, butane, hexane. The more number of carbon atoms, higher the boiling point. That's all. The more number of carbon atoms, higher the boiling points. So that's the important takeaway from this. Halogenation. We just now discussed. Correct? We discussed what? We just now discussed reduction of what? Alkyl halide I discussed with you, right? In presence of HCl. That same thing, only this. We just now discussed. We just now discussed the same thing. So they just gave halogen means adding halogen to methane. Will give me alkyl halide plus HCl. The same thing we just now discussed. Suppose if you don't remember this, I'll just show to you. Wait. Yeah. Can you see this reaction CH3Cl plus HCl? I wrote it HCl here, right? Plus methane plus what? Methane plus chlorine. That same thing only is written here. So if we study the preparation again, the chemical properties and all will be easy. The same thing only it is there. So again, we have to just relate it. Combustion, which means presence of oxygen. If I heat any hydrocarbon, this already I told in the classes many times. If I heat any hydrocarbon, I'll get smoke. That is carbon dioxide. Leftover thing will be water. Combustion. Controlled oxidation in the sense, yeah. Again, I just told you this is a land of exception. Now I just told what? We'll be getting carbon dioxide and water. But now again I'm telling you, if I keep this is at 100 atmospheric pressure and heat it at 523 Kelvin, then I'll be getting an alcohol. So here it is methane plus oxygen is giving me methanol. This I'll come to the last. Reaction with steam. So if I pass any alkane with steams, steam is water, correct? Hot water. I'll get carbon monoxide and hydrogen. That's all. So nomenclature, if you don't know, let me know. I'm not going to discuss now here. So how do you prepare alkene? Same thing. Alkane, how do I prepare? From alkene with hydrogen. Here, alkane plus hydrogen. Relate and study. It'll be easy for you. From alkyl halides, same thing. Alkyl halide is what? RX. CH3, CH2 is ethyl chloride. Correct? Yes, one of the hydrogen is being eliminated. Correct? One of the hydrogen is being eliminated and it will join with chlorine. So HCl I'll be getting. If you're not understanding this, see here CH3 is there, no? In CH3, one of the hydrogen will join with this chlorine. Then I'll get alkene. That's all. If you don't know this, again, once the class is over, I'll help you out. So no need for you to worry. But with that, kindly listen the class carefully. From alcohols by acidic dehydration. If I heat an alcohol, correct, with sulfuric acid, then water molecule will be removed from this. In the sense, I'll just show you what is being removed, because if I just say, you won't be able to get it. This HO will be removed plus one of the hydrogen from this. This H3 will become H2. One of the H from this H3 is removed. So this H plus OH will become H2O. I'll get alkene. Simple thing only. See, they will use the term elimination and all, but don't get worried or confused. But the important thing is almost done. Okay, Marco-Nico rule and anti-Marco-Nico rule. That is the most important thing. Again, physical properties we have to know. The first three members are gases and the next 14 liquids and the higher ones are solids. Colorless gas, same property. Insoluble in polar solvents, same thing as alkane, but soluble in polar solvents. So same thing. Whatever I told, the same thing. More number of carbon atoms, boiling point will be more. That's it. So if we study one thing properly, we can do the other things also very easily. Addition of dihydrogen. In the sense, whatever we studied with alkane, the same thing again I'm repeating. Alkene plus H2 will give me alkane. Addition of halogen. Correct? Addition of halogen is what basically alkene plus halogen will give me alkane. Will give me what? Alkane. Haloalkane. This is called haloalkane. This particular thing. I'll share you these things once the class is over. So no need for you to worry. I'll just go a little bit fast. Because most of the things are self-readable. Marco-Nico rule, anti-Marco-Nico rule already I explained. So that I'm not going to do that. Polymerization. Polymerization is nothing but, we all know polythene cover, right? Polythene. So that is poly meaning many. Ethene we know. Correct? Many number of ethene molecules stacked on top of one on top of other. This is called what? Polythene. So one ethene molecule is called monomer. Many is called polymer. Okay, so that's the reason. Alkene, if I keep one ethene on top of the other, the bond will break and it will give me this one. The bond is breaking. Alkyne. Again, the naming, I'm not going to do it now. If you got doubts, let me know. So preparation from calcium carbide. I'll come to this first. Calcium carbide, will take it last. or maybe in the class directly. Yeah. So from vicinal dihalides. So this is my haloalkane with KOH. Potassium hydroxide is my strong oxidizing agent. This will give me what? Alkene. And then on further treatment with what? Hydrogen, H plus ions. I'll be getting my alkyne here. This is how the preparation of alkane is being done. Physical properties, same thing as that of uh, the alkenes, but only thing is that in alkenes, the next 14, the first three members are gases, the next 8 are liquids, but in alkene, it is next 14 are liquids. But again, we have to be very careful on these physical properties. Colorless, odorless, and all is correct. Yes. And same properties as that of alkene and alkene, so there is no much difference. The same. Addition of halogen, same thing. Addition of halogen also same thing. Alkane contains triple bond. So end of the day, I'll be getting my single bonded thing. So same thing as that of my alkenes. Addition of hydrogen halide. If I add hydrogen halide, there we did HBr and all, no? Triple bond will be broken down to double bond. That's all. There double bond is broken down to single bond. Triple bond broken down to double bond. Addition of water. If I add water to alkene, I'll get a ketone. I'll be getting what? A ketone. Carbonyl compounds. Polymerization. Yeah. Again, so here I'm talking about ethane. Polymerization, ethane. There I talk about ethene. If I add n molecules of ethene, ethine, I'll be getting what? Ethane, correct? I'll be getting ethane. But now if I add n molecules of ethine on top of the other and in a red hot iron tube here as it is written and heat it, then I'll be getting a benzene. Benzene, C6H6. Benzene is C6H6. Oxidation, same thing. Any hydrocarbon will get carbon dioxide and water. And this is my benzene thing. And resonance is nothing but just to show that the nucleus remains same and more acidic nature. This will be the highest acidic nature compared to alkene and alkane. Preparation is done. Yeah. And this is nothing but the reaction decarboxylation of aromatic acid. In the sense to get a benzene, preparation of benzene. Correct? CONA. This is called sodium benzoate. Sodium benzoate, this molecule is called. Plus sodium hydroxide plus calcium oxide will give me what? Benzene and sodium carbonate. Preparation of benzene. Phenol is nothing but benzene with OH. Benzene with OH is called what? Phenol. If I treat with zinc, I'll be getting benzene. This is my benzene. So remember always what is our preparation. Properties, same thing as that of alkane, alkene, and alkane. And what is this benzene? Basically, we have naphthalene balls used in our home, right? That is actually benzene ring. And they burn with a sooty flame. This also in the entrance they can ask. Chemical properties of benzene. Nitration. Benzene with what? Constant nitric acid. Yes, will give me what? What is NO2? Nitrobenzene. Halogenation. Halogenation is adding halogen with the benzene. Adding halogen with the benzene. Correct? I'll be getting a chlorobenzene here. Anhydrous aluminum chloride. Anhydrous aluminum chloride is nothing but to remove the water component. That's all. To remove the water component. Yeah, and chat section, I got some doubts. I'll clear it once the session is over. And physical properties, again, you can read it same thing only. This is nitrous. Yeah, I think it's almost done. Yeah, and the last important thing, feudal crafts. This they can ask. Benzene ring with hydrogen. What is this thing? Alkyl halide. That is, alkyl is what? CH3. Halide is what? Cl. Anhydrous aluminum chloride will give me what? CH3. That is toluene. See, just remember, benzene ring with OH is called? Benzene ring with OH is called phenol. Benzene ring with CH3 is called CH3. Sorry for the bad handwriting again. Toluene. Yes. So that's it regarding the session.